Okay, we're just going to make a short video here to kind of expand on the last one, dealing with equivalent fractions. In the last video, I looked at really the concept behind equivalent fractions, and we entered into some practice with how can you do that without having to draw a picture every time. This is just to give the kids some practice with these problems where you have to go ahead and find an equivalent fraction with a certain value. And as I look at our 5 here, it's not coming across on the video well, so we'll remake it. So what I've done here, I've set up 4 problems, and I'm going to hit pause for a moment, and I'm going to let you copy the 4 down, and then we're going to work through them together. So if you want to go ahead and hit pause right now, and in a moment we'll talk about these. Okay, I hope you had a chance to get this copied down. We're going to look at 2/3 first, and if we think about what 2/3 means, that means I have an object divided into 3 parts, of which someone is getting 2 of those parts. What the equivalent of fractions allow me to do is to change this fraction so that the number of pieces total changes. So if originally the object was divided into 3 parts, now it's going to be divided into 15. But I still need to make sure you get your 2/3. So what we need to do now is look at this numerator of 2, because in the end, when I give you 2/3 or something 15ths of this object, you should still have the equivalent of your original 2 parts you were getting. It should not change the amount you get, just the size of the pieces it takes to give that amount to you. So if we look at this for practice, I look and say, okay, the original object's divided into 3 parts. We need 15 parts. Because there is a number, a factor that 3 can be multiplied by to get 15 as a product, that means I can find an equivalent fraction with 15 parts. Now, say this had said 16, then no, we have a problem now, because there is nothing I can divide or multiply, 3 by. There's no factor times 3 that will give me 16. So that would not be making an equivalent fraction, and you do put yourself in danger of not getting your original 2 parts you wanted to get. So we're going to 15 parts. What do I multiply 3 by? What factor times 3 gives me 15 as a product? And hopefully you've had a moment to think about that. And of course it is 3 times 5. So really what we're doing is we're saying, okay, I'm going to multiply by 5. 3 times 5 is 15. Whatever I do to the denominator, I did to the entire object, including the 2 parts you were going to get. So my numerator is also multiplied by 5. Sorry, I'll make this one a little larger. Just getting used to a new board we're trying here. I want to make sure it's still something you can read. So 3 times 5 is 15. 2 times 5 is, well, hopefully you came up with 10 15ths. Right now what I'd like you to do is try this next problem. 7/9, I want to convert it to an equivalent fraction that is going to be something, we don't know what yet, 27ths. So I'll give you a moment, and I'll be back with you in a second, see if you can find the equivalent fraction. Okay, hopefully you've had time to try that one. Did you come up with 21 27ths? I hope you did. What I saw was that 9 times 3 is what gives me 27. So the factors of 27 are 9 and 3. Because I multiplied the denominator by 3, the rule says if I split the whole object up into 3 times as many parts, that includes the pieces that I'm giving away. Those 7 pieces also got divided up into 3 parts each. 3 times 7 is 21. So hopefully you came up with 21 27ths. This is something you can practice doing a lot, but I will point out that this is another one of those places where knowing your multiplication facts is so important. You should be practicing that every day, guys. Even if it's a matter of just counting by numbers. If I count by 7s, I would recognize 21 as a multiple of 7. 7, 14, 21. So we really do need to be practicing the multiplication facts every day, even if it's just taking one set of numbers to say, and that's the one I'm going to focus on today. These have to start coming very quickly, because the next thing we're going to look at is something that, again, being able to multiply and know your multiplication facts is going to help you, because we're going to turn it around and do the opposite of multiplying, because sometimes fractions actually can be reduced. So rather than multiplying, we instead would divide. Now this only works if, for example, the fraction, or not even for example, they have to be. The numerator and denominator, the only way you can divide them both is if they both have a factor that is common between them. So for example, with 15 and 20, 15 and 20, I'd be looking to see if there's a factor that will go into both 15 and 20. In this case, to reduce 20 down to a 4. Well, this is where knowing my multiplication facts comes in handy. I have to ask myself, what times 4 gave me 20? Because that's what I need to divide by. And of course, that's 4 times 5. Well, in this case, then, to go from a larger number in the denominator to a smaller number, instead of multiplying, I can also divide. In this case, divide by 5. Whatever I do to the denominator, I should be able to do to the numerator. So if I divide the denominator by 5, I should also divide the numerator by 5. But here's the catch. It has to be divisible, meaning that that number has to be able to come out of 15 without a remainder. It has to come out of it evenly. Thankfully, with 15 divided by 5, it does, because what times 5 is 15? 3. Very good. 15 divided by 5 is 3. So I end up with a new equivalent fraction of 15/20, which is 3/4. I'm going to give you a moment now to look at 16/24. Again, this is a problem where instead of multiplying for 16 here to become a 4, we aren't going to be multiplying. We're going to be dividing. I'm going to give you a moment right now to do that. Okay, and we're back. How did you get 16 to become a 4? Well, we ask ourselves, if you don't have it, what times 4 gives you 16? Again, this is a matter of knowing our multiplication facts. Well, that would be 16 divided by 4. 16 divided by 4 is 4. Well, if my numerator, those pieces I'm giving away, those 16 pieces and now 4 pieces I'm giving away, that should have the same value even though the numbers have changed. I mean, it's like that we talked about with the dollar bill being split into two 50-cent pieces. You're still getting the dollar, you're just getting it in a different way. Well, if I divided the 16 by 4, that means the entire object was divided by 4, including all pieces. And remember, that's what the denominator really means, all pieces. So 24 divided by 4 is, you have it? That's right, 6. That's not a very good 6, but there's our 6. 4/6 is our fraction that we have simplified to. Now that will lead us into our next video, which I'm going to still try to get out for you this weekend, which is simplifying fractions, because essentially that's what we're doing here, with the goal being also to not just simplify them, but to get them to simplest form. Something to think about as we leave here. If simplest form is the fraction reduced so that it can't be reduced anymore, which one of these two is in simplest form right now? Is it the 3/4 or the 4/6? Look at them carefully. If you look at 3/4, can it be divided by anything other than 1 at this point? No, it can't. 4/6, on the other hand, is there a number that 4 and 6 have in common that they could both be divided by still? They're both even. There's your hint. 2. Right. If I divide 4 by 2 and 6 by 2, I would still get one more equivalent fraction to this one. 2 thirds. So 3/4 was the number that was already in simplest form. And that's what our next video is going to be about.